So ionic compounds. Ionic bonds are formed when we have a transfer of electrons from one atom to another. One atom just flat out gives its electrons to another atom. And that causes a force of attraction between the opposite charges. And we can illustrate this with Lewis structures. So we're going to look at the formation of sodium chloride. So sodium, yeah, that's the wrong thing. I wanted my pen. Here, sodium and chlorine. How many valence electrons does sodium have? 1. And how many does chlorine have? 7. 1, 2, 3, 4, 5, 6, 7. Okay, so there we have Lewis structures for sodium atom, chlorine atom. And what's going to happen is that the sodium, let's pick a different color here, the sodium is going to give this electron to the chlorine. So when that happens, sodium has cleared out its outer shell. Does that mean it has no electrons? No. It just peeled off that incomplete outer shell, and what's underneath is a full shell. That gives sodium a charge, though, right? I have to tell you a joke. 2 sodium atoms were walking down the street, and one ran into a lamppost. He's like, ow, I think I lost an electron. And the other atom says, are you sure? And the first one says, yeah, I'm positive. Lost an electron. Yeah. So by losing that electron, sodium becomes a positive ion. And chlorine now has gained an electron, so it becomes a negative ion. Because the number of protons and electrons are not equal anymore. The number of protons in an atom doesn't change. That's like your soul. You can change the color of your hair. You can pierce things. You can dress weird. You can do all kinds of stuff to your body, but you can't change who you are, right? You're still you. I know some people don't like that, but it is what it is. Chlorine still has 17 protons, but now it's got an extra electron, so it has a charge. Now what we have is this sodium ion that has a positive charge and a chloride ion with a negative charge. Opposites attract, and these guys are going to stick together in much the same way that magnets stick together. What's happened here is that chlorine has filled up its valence shell. If we look at the periodic table, what's next to chlorine to the right on the periodic table? Argon. How many valence electrons does argon have? 8. 8's kind of like a magic number. Okay, so we're going to see that atoms are going to interact either through covalent bonds or ionic bonds in order to get 8 valence electrons, a full valence shell. Sodium has done that by losing, because from sodium at 11, if you go around the back of the periodic table, you get to neon with 10 electrons. This sodium ion now has 10 electrons. How many valence electrons does neon have? 8. And so by transferring this electron, they each now have 8 valence electrons, and that's like a happy place for atoms. Any questions? So cations are positive. They become positive by losing electrons. Important to remember that cations are positive. I like cats. I have positive feelings for cats. That's not going to work for all of you, but it works for me. Cations are positive. Anions are negative. There's an extra N. They both end in ion, but this one has an extra N in it. Anions are negative. Got to keep those straight. And an ionic bond is just this electrostatic attraction between the charged ions. That's what an ionic bond is. So as I kind of mentioned, the atoms are going to gain or lose electrons in order to get a filled shell. For the smaller ones, like hydrogen, a filled shell is 2. Hydrogen is like the baby brother of the family, and he gets to break the rules and be an exception to lots of things, right? So hydrogen is only trying to get 2 electrons. Most of the elements, though, are trying to get 8 electrons. Nonmetals tend to gain electrons. We say they are electronegative. They attract electrons. Metals are electropositive. They tend to lose electrons, and they're going to form cations. So let's predict charges. What charge would an aluminum, oh, I left out a word, ion. What charge would an aluminum ion have? 3 plus. And one way we can figure that out is by looking at the Lewis structure for aluminum. We look at aluminum, it's in group 3A. It has 3 valence electrons. To get a full valence shell, the easiest way is to lose those 3 electrons and get rid of those. And if we take away 3 electrons, then we have a 3 plus charge. What about sulfur? Negative 2. Sulfur has 6 valence electrons. 1, 2, 3, 4, 5, 6. It wants to get to 8. Now, it could lose all 6 of those, but nonmetals don't lose their electrons. They get extra electrons, okay? So if it gained 2 electrons, it would have a full shell, and that will give it a charge of negative 2. Any questions? So ionic bonding is one type of bonding. The covalent bond is another. We look at this word covalent. Co means sharing. Valent, sharing valence electrons. So between nonmetals, they both want to gain electrons. And so say 2 fluorine atoms are trying to form a bond. One fluorine atom is saying, hey, give me an electron. And the other fluorine atom is like, no, you give me an electron. Nobody's willing to give up an electron. They can't form ionic bonds. So they share the electrons and form an ionic bond that way. So a covalent bond is this attraction caused by the sharing of a pair of electrons. So let's look at fluorine, since I mentioned him already. We know from the periodic table that each fluorine atom has 7 valence electrons. And so, let's pick a different color here. So this fluorine wants 8 electrons, this fluorine wants 8 electrons. And if this fluorine atom is willing to share its electron with that one, then that guy has 8 valence electrons. And this guy has 8 valence electrons. Because those shared electrons count for both. My husband and I have 6 children. I have 6 children. If you ask me, how many children do you have? I have 6. If you ask him, he says, I've got 6. Are there 12 children running around our house? No, thankfully. Love them to death, but there's plenty of them already. So this fluorine atom counts both of the shared electrons, just like I count all the shared children, and the other fluorine counts both. So those electrons, in a sense, do double duty. They get counted for each. But this is how each fluorine atom can get a complete shell by sharing instead of transferring. Oh, I kind of already did that one. I get ahead of myself sometimes. When we have a covalent bond being formed, heat is liberated. Heat is given off. And to break a bond, you have to put energy in. It's the same amount of energy that you have to put back in to break that apart. And that is called the bond energy. And we usually express that for 1 mole of covalent bonds. So as an example, the bond energy of a hydrogen-hydrogen covalent bond is 104 kilocalories per mole. So to break a mole of hydrogen bonds is 104 kilocalories. That energy is going to vary depending on the type of bond, which atoms are involved, and whether it's single or triple or double. We also talk about bond length, and that is the distance between 2 covalently bonded atoms. Since atoms are very tiny, this is also going to be very small. The length of a hydrogen-hydrogen bond is 0.74 angstroms, or 74 picometers. Teeny tiny. But bond energy and bond length are often related in a way. If the bond is very long, it's going to be easier to break than if it's very short.